Okay. Death by PowerPoint, not happening. We're going to do something slightly different with this session. As you can see, a slightly different sort of fireside chat kind of activity. And I will just hand over to Vin Ratford, Executive Director of the Embedded Vision Alliance, to explain a little bit more. Vin?
Well, thank you for joining us right after lunch. Hopefully we can keep you awake. We have an interesting guest here today, Bill Lee, who's the CEO of Knightscope, which he'll talk a bit about the company and himself. Hopefully you'll find this talk interesting. I certainly did, and I'm sure Bill will have a lot to say about the product and the company. So let's start by having Bill talk a little bit about his background.
By way of background, I'm an ex-Ford Motor Company executive, so I'm reasonably fluent in, I'll call, large-scale hardware outdoors. I believe that self-driving technology, autonomous technology is going to turn the world completely upside down. I think the path that everyone's taking is trying to go to Pluto first instead of stopping over at the moon. So we've got a decidedly very different approach to commercializing autonomous technology in a maybe crawl, walk, run approach. Also, I was born in New York City. Someone hit my town on 9/11. I'm still pretty upset about it. So I'm dedicating the rest of my life to better securing our country. Maybe to give you a little macro political perspective on that, that most audiences don't really understand or appreciate. The US Department of Defense has a $700 billion budget. It gives the troops every level of capability you might ever imagine. There's one person in charge. There's a process. There's a Northrop Grumman, a Lockheed, a Raytheon, a Boeing to build you whatever you want. You want a new tank, you want a new jet fighter, you want whatever missile capability you might desire, it's there to be built. It might be expensive, but it gets done. What's really odd in our country is crime has a $1 trillion negative economic impact on the US every single year. It's a hidden tax we all pay in blood, tears, and treasure. So when someone shoots up a synagogue, a movie theater, or a school, tell me, who gets fired?
Nobody.
No one gets fired because no one's accountable. What do you mean no one's accountable? Well, let's look at it structurally. The US Department of Homeland Security and the US Department of Justice have no federal jurisdiction over 19,000 law enforcement agencies and 8,000 private security firms. There's no one in charge, there's no risk capital, there's no innovation, there's no process, and it's basically the wild, wild west. And that's why at 3 o'clock in the morning, you've got a security guard sitting in there in the parking lot with a number 2 pencil and a notepad. And somehow, the math that I have a huge problem with is there are 1 million security guards in our country, 1 million law enforcement professionals. So that means 2 million people get up every morning, are willing to take a bullet for you and your family, and the level of technology that we provide to them as a country is beneath the dignity of this nation. And so how 2 million people are supposed to secure 328 million citizens across 50 states is beyond me, right? And what happens when some horrific thing occurs again? Both sides of the aisle, we extend our thoughts and prayers. Hey, buddy, that's not gonna fix the problem. So what we've been trying to do is build an all-new set of technologies to give the 2 million brave women and men in uniform really smart eyes and ears for them to cover a lot more ground. And that's basically the genesis of how we got started on Knightscope.
So this is a security robot, and I remember the first time I saw the video, I thought, this thing is massive. It's 400 pounds, it moves at 3 miles an hour. Why is it so big and why is it so massive, and does it actually have any computer vision technology in it? So maybe you can help us understand why.
So the strategy is twofold, one less obvious than the other. So if I put a marked law enforcement vehicle in front of your home or your office, what happens? Right? Criminal behavior goes down, criminal behavior changes, rather, and most of these guys, are trying to just get away with something and find the path of least resistance. You pull into a hospital parking lot at 3 o'clock in the morning and there's a 5-foot-tall, 400-pound machine roaming around fully on its own, strobe lights going, says security on it, you have no idea what it does. I think you're gonna steal the car down the street, not there. And that's literally what's been happening with our clients. So just having that physical deterrence is one reason why you want to have a bit of a larger presence. The second is on the detection side. So we want the machines to do the monotonous, computationally heavy stuff that no human could ever possibly do. So for example, some of our machines have facial recognition on them. Some of our machines can detect any mobile device in the area within 400 feet of the machine and detect if that device has been in the area before, how long it's been sitting there. So let's say in Times Square, why hasn't that device moved in 17 hours and 22 minutes? Is that because someone forgot their phone or lost their phone? Or is that something a bit more nefarious? Or someone shows up with four signals at a secure data center. Okay, high risk of industrial espionage. Most people don't walk around with, most people, maybe around here, I don't know. Most people don't walk around with 4 cell phones. On the computer vision side of things, it's been a little bit of a challenge. So in the security industry, a lot of the, let's say, detecting a person. You've got a fixed camera, fixed foreground, fixed background. You're doing pixel differentiation to kind of see if anything changed. Why can't you just port that over to your stuff? And we tried. Doesn't work. Why? Camera's moving, foreground's moving, background's moving, objects moving. It's raining, it's sunrise. Now tell me this is a person and not a fire hydrant. Like that, we had to end up starting from scratch. So doing people detection on the fly, and then doing optical character recognition so we can read 1,200 license plates a minute and run it against the database if need be. And we had to build all that OCR stuff ourselves, again, for the same problem. A lot of the security technology has been out there has either not been robust or not used the way we use it. So we had to kind of start from scratch, which was bloody painful. But we got it working, and we're grateful for everyone that invested all the time, money, and effort into all the computational capabilities and machine learning algorithms that are out there for us to leverage, for us to be able to do that. But we spent the last 6 years now building a platform that actually works 24/7, 365. I don't think I'm speaking out of turn. I believe, depending on how you want to do the math, $40 to $80 billion has been invested in self-driving technology. There's 50 to 200 companies working on it, depending on how you want to characterize that. I believe Knightscope is the only company in the world operating 24/7, 365 across an entire nation, from California to Puerto Rico. That's 5 time zones, fully autonomous without any human intervention. And so we've been able to commercialize the technology, but it's been a bit of a challenge.
So talking about the technology a little bit more, this is a very engineering audience. Maybe you can talk a little bit about some of the technology that's inside the product, some of the sensors, some of the battery technology.
Sure.
Maybe just for the audience a little bit.
Maybe cut it in 2 pieces. One, you want to think of this basically like a self-driving car. So we use LiDAR, sonar, wheel odometry, accelerometers, and then a bunch of crazy software to simultaneously map an area and localize or find yourself in that location. And you got to be able to do that dynamically in really crazy indoor environments and outdoor environments. So 3 o'clock on a Saturday inside of a mall, it's complete mayhem, right? Kids, people, that's all that stuff. You got to be able to navigate through that. Or 24/7 on a 9-story parking structure in Denver, where you're going up and down, and there's people in cars, going all every which way. So think of it as basically a self-driving car with the same kind of technology stack. We try to do as much onboard processing as possible. 90+% of our clients are on LTE in some form or fashion. So we can't be going up and down, especially at $5 or $10 a gig, much less the latency issues. So we try to do as much onboard processing. So when we started the company, we never uttered the word GPU or the acronym. So we started with an Intel i7, did all the navigation and as much as compute we could do on there, and then quickly kind of ran out. So now we've got Intel i7s on there and NVIDIA GPUs on board, and there's different kinds of data out of these machines. So we call them autonomous data machines or security robots. They generate over 90 terabytes of data a year, so no human's going to be able to ever process that. Some of that data is navigation related, right? So we can't keep all that, so maybe every 8 or 24 hours we're dumping that. There's a terabyte of storage on the machine, so we can keep up to 2 weeks of client related data. we try to do as much onboard processing as possible. Sometimes you have to go up to the cloud and back down. So for example, the machines, a security guard can speak through a machine as if it was a mobile PA system, or you can have a two-way intercom call, or you can have a machine to human interaction similar to a Google Home or Alexa. Well, you got to do the speech to text and then up to the cloud to interpret and then back down, right? So there's some going back up and down. And in a lot of cases, our clients might ask us to be on the lookout for. Let's say you're a corporate campus and you just terminated an employee, or you're a school and you're worried you just expelled a student, you're worried they're going to come back. You can blacklist their mobile device, or devices. You can blacklist their license plate. For the K1, you can blacklist their face. And then we're on the lookout. So that data you don't want to override. So in that case, if something happens at a particular event, let's say at 2:21 in the morning, we detected something that you told us to be on the lookout for, we'll send -8 minutes and +8 minutes of that event up to the cloud for forensics and what have you.
So there's a lot of technology inside that package. And
Yeah.
Maybe you can talk a little bit about the customers, because I found some of the applications quite interesting. So talk a little bit about the customers, and then how did they use the product and the services, and then, how does it fit in with the existing security team that is maybe at the customer's site?
Customers are fascinating, and we're in uncharted territory. No one's ever done this before, so we're having all kinds of odd conversations. So some of our clients, in no particular order, so malls like Westfield in California or New Jersey, casinos, Stadium, the Sacramento Kings are a client of ours, corporate campuses like a Samsung, a Seagate, a TD Ameritrade, banks like Citizens Bank, a lot of commercial property, hospitals, Dignity Health, Houston Methodist, logistics facilities, I think are going to be interesting for us. So we're with XPO in Atlanta, California, and North Carolina. And those get really interesting because they've got several hundred facilities, and we can continue to expand with them. Probably some fascinating stuff that I kind of didn't expect. We had to buy a printer, I guess almost the size of that screen. Almost every client wants their machine branded. So I never, for the life of me, thought someone's going to take their multi-million-dollar brand and want Citizens Bank on the side of it. And then to top it off, almost all the machines are named. So there's Steve, there's CX3PO, there's Rosie. You have to have odd conversations with the client, like, do you want a male voice or a female voice? Wow. We showed up at a couple of clients that had robot cakes ready for the first day.
I would want Arnold Schwarzenegger's voice in my machine. So.
I think there's a small fee associated with that, but it's been really interesting. But our clients, basically anywhere indoors or outdoors, you might see a security guard, fair game.
Very interesting. And, I found the business model to be really quite interesting. You use the term MaaS or machine as a service, not mobility as a service, which is another version of that. So maybe you can talk a little bit about that model. I also found the ROI really quite compelling. So maybe you can talk a little bit about that.
Sure. Back in Detroit, we could barely cover our cost of capital, so selling hardware on its own, probably not a good idea, especially for a big ticket item like this. So maybe I'll cover that question from two different perspectives, one from the client's perspective and one from the corporate or our investor's perspective. The client gets kind of really animated. Why? An off-duty law enforcement officer, and these numbers range widely across the country, but it's about $85 an hour, armed guard, right? Armed off-duty police officer. And unarmed, which is 90+% of the security guards out there, you're in the $20 to $35 an hour range, right? And mind you, that's what the client pays, not what the guard gets paid. We offer our technology, depending on which machine, at an effective price of $6 to $12 an hour. So we sign year-long contracts running 24/7. So each contract's going to generate, let's say, $70,000 to $100,000 a year. Each machine says designed and built in Silicon Valley. We physically build these ourselves. I get kind of frustrated with some folks say, who designed all this stuff? Well, you're looking at half the design team, but we did. My chief design officer is also ex-Ford. So who did all the mechanical engineering, all the software, the firmware, all the electrical? We did. So where in China did you get these built? And I'm already about to blow at that point in time. Let me take you out back, and we're based in Mountain View here, and we physically build them ourselves. It costs us around, plus or minus, about $60,000 on a bill of material for majority of the machines up there. And so the business model is to recover the cost of the machine in the first calendar year. Second, third, fourth, fifth year, you're basically just printing money, right? So on the high side, just to round up the numbers, each machine should generate about $500,000 of revenue over a 5-year business planning period. Costs us 60 grand to build one. We set aside $190,000 for service, support, unlimited firmware, software, at times hardware upgrades. Something breaks, something gets smashed into, whatever, it's all on us. So that $190,000, you want to, in old school parlance, might be warranty reserve or something like that.
Sure.
And so each machine should generate about $250,000 of profit over that 5-year period.
Yeah. One thing I found really interesting was I didn't have an appreciation for the role of security people, what they can do and what they can't do. And you use the term observe and report.
Yep.
They don't carry tasers, they don't carry guns. So maybe you can talk a little bit about what they do and how they partner with the security team on the site, because you also have sort of a security operations center software panel that is used as well with the product, right? So
right.
Talk about that.
So the guarding industry is pretty bloody awful. It's 100 to 400% employee turnover rates. That means they can't keep the person on the job, no more than 3 to 12 months. This is worse than the fast food industry. So you got a lot of onboarding, offboarding, not a lot of training. So you put that in combination with we're the most litigious society in the world. And so the guarding companies, the last thing they want to do is be liable for an untrained person to intercede with something. And a lot of interesting critiques we get on social media is like, well, it doesn't have a gun and you can't intercede and this, that, and the other thing. Is like, well, less than 7% of the guards are armed. They're contractually obligated to observe and report only. They are not to intercede. So it's kind of exactly what we do. Don't quote me here. I think it's 17 or 18 states. It's actually illegal for a guard to put their hands on you. So we provide them a browser-based user interface that you alluded to that gives the guard maybe a different perspective. So instead of that guard quitting their job every 3 months or 9 or 12 months, imagine if you can promote them and say, all right, hey, these 7 robots now report to you. Here's a desktop, mobile, or tablet that has access to all the machines. You can schedule where they go, what they do, what detections. Now you've got eyes and ears across this entire campus, and now you can actually do your job much more effectively. And every 10, 15 years, we have this societal, drama episode. The robots are coming, they're gonna kill everybody, they're gonna take everyone's job, including everyone in this room. And it's a little bit silly, it's, when electricity first came online, probably the conversation was something like, kind of dangerous stuff. I've seen it kill people. We should probably not go down that path. Or the ATM, you're never gonna see a banker ever again, right? That conversation keeps going on. And now people are realizing like, oh, this stuff actually is helpful. It's early days, but we've helped a law enforcement agency issue an arrest warrant for a sexual predator. We helped another law enforcement agency apprehend an armed gunman. We helped a security guard apprehend a thief. We stopped a corporate vandal. We stopped a fraudulent insurance claim. Like the list goes on, and we're just getting started. So our kind of grandiose, long-term, crazy mission is we like to see if we can make the United States of America the safest country in the world and literally change everything for everyone. And if you just pause reality for one moment and let the lunatic founder say his piece, imagine if we were actually able to do that. Talk to me about the impact on the volatility of financial markets. Talk to me about the impact on insurance rates. the value of your home, the viability of someone's local business, the safety of your family. Like literally everything changes for everyone. And that's why we have the honor and privilege of waking up every morning and trying to do something about the horrific environment we live in. I don't believe the founders of our country ever expected us to build a society where going to work, going to school, or going to a movie theater literally came with the risk of being shot or killed. It's just not acceptable. And it's high time somebody does something about it.
Well, I think it's a noble mission. It's an important mission. One of the things I did notice is you've got some new products in the pipeline. I find the K7 to be kind of interesting. It looks more like a typical autonomous vehicle. So maybe you can talk a little bit about the kind of products that are in the pipeline and the kind of things that you see happening as the products and the business evolve.
Yes, I need to curtail that a little bit. We're a semi-public company, so we report to the SEC every 6 months as if we were publicly traded, but the stock is not yet on an exchange, so I need to careful what I say here.
Okay.
What's up on the screen there, there's 3 of them in production today. There's a stationary machine, the K1. The K3 is primarily for indoors, 4 foot tall, 2 foot wide. The K5s are the most popular model that's primarily used outdoors. And that's actually the 4th generation machine that we're shipping now. We've now operated more than 700,000 hours. We've survived our 2nd winter. So we've got a lot of lessons learned. And the K7 is what you're alluding to. So that's the size of a small car. It's intended to handle much more difficult terrain. We've got still probably another year's worth of work after we get this financing done to get that one out the door. So that one's intended to handle gravel, dirt, sand. So think around 8 miles around the perimeter of an airport, a solar farm or wind farm, an actual farm. This might sound funny, but a farmer calls up from Florida. Hey, I pay the sheriff $50 an hour to patrol our avocado farm. It sounds a little odd, but the margins on avocados are kind of serious and people keep stealing their stuff. Like, I think we can beat $50 an hour, so we'll kind of figure that out. Wow. And then as an ex-auto executive, there's 1, 3, 5, 7. There's a lot of numbers above 7. I'll leave it at that. A couple science projects that we're working on that we're making some progress on. It's something that the clients really, really want. It's technologically very difficult to do, is weapon detection. So we're working on visible weapon detection. So someone's brandishing a firearm in an area they're not supposed to. Kind of easy to do in a laboratory or constrained environment, but with all the kind of different lighting conditions at night, someone's wearing black clothing, or it's sunrise or sundusk, or you get partial, and there's how many weapons, that's a lot. But we've got kind of the first prototype working, so we're pretty excited to kind of move that along. And then the harder one is the concealed weapon detection. Yeah. Someone's carrying a firearm underneath their clothes or has a bomb vest or something like that. So long term, what we want to be able to do is have these machines see, feel, hear, and smell. And there's going to be a lot of computation going on that machine to be able to have all those kinds of capabilities.
That's fantastic. So this will be my last question. So if you have a question, start heading towards the mic. So that kind of leads to, you're here at the premier computer vision conference on the planet. Some of the best computer vision developers are out there. What 1 or 2 things would you like to have that you don't currently have that the audience might be able to help you with?
So I've been to a lot of conventions, including security ones. I think one thing we're missing is just not enough cameras, and they just don't change often enough. I mean, the amount of stuff that's out there is just too much. For us having a stable architecture that can be a rinse and repeat would be a lot better. I think there's still too much of customizing for this particular edge case or use case. And so one of the things my engineers and I are shopping for here is for our next generation kind of video architecture, camera, all the piping and the boards and stuff that go with that to improve our machine learning algorithms and capabilities. And there is almost too many choices which in some cases for engineers is really good, but at some point in time, you need to kind of constrain it down to something. For what we're looking for, one is redoing our own video architecture, as I mentioned, but anything that in the short or long term can help us see, feel, hear, or smell, we're genuinely interested in. And in a lot of cases, it needs to be production ready. We've got existing clients. We can't do too many science projects. So it's got to be rugged enough and suitable for the kind of environments that we're dealing with.
Audience, anybody have any questions out there? Step up to the mic if you do.
Hi there, I'm Chuck White.
Hi, Chuck.
First, your vision is noble and inspiring, and I hope you succeed wildly.
Thank you. Thank you.
Can you talk a little bit about data, how you got it, curated it, how you validate that this thing is sort of safe and it does what you expect it to do from both a development and a validation standpoint?
Probably the quick and dirty answer, looking at the clock here, you cannot build this kind of technology in a laboratory. We've, in some cases on the data side, you wouldn't have gotten that edge case if you would not have been actually operating out in the field. And I tell our investors and I'll tell our partners and our clients, we've had, I think, maybe 3 minor incidents over the last 6 years. To put that in context, in the auto industry, mature industry over 100 years old, there's 15,000 accidents that happen every day. So just to put things in context, I think you need to be out in the field. You need to bump your head. You need to break stuff, go back, fix it, and keep going. And there's no way, probably the humorous story would be, you would never call a meeting to address the hug test. Like a girl decides to just grab the robot, hold on for dear life as they do their selfie or whatever, and leave a nice big kiss on it. Like you would never call the meeting to figure out like, hey, how are we gonna figure this out now, right? There's a lot of cases like that. So it's a lot of, probably the easiest way is a lot of lessons learned and just keep going through the data and making it better and better and better. It's one huge, massive, continuous improvement exercise, as opposed to in Detroit, like 400 employees, 400 prototypes, $1.6 billion later in 4 years, and out the door you go, here's one SKU, and you ship it. That's not what we do.
I think we have another question. Go ahead.
Hi.
Hi.
Again, amazing conversation there. My question is that a lot of autonomous vehicle companies use a very interesting KPI to map their success, which is that after how many miles did a human have to intervene, right? So I would like to ask about the similar KPI. What is it for you? And
How many disengagements, right? So the funny and hard part about this, despite what the media thinks, there's nobody inside. So like we don't have a disengagement metric. Like we got to operate 24/7 and we got to kind of be right 100% of the time. So what we do have is a staff that runs 24/7. I guess maybe similar to a data center or a telecom. You've got hardware, software, and humans making sure that the network is operating and all the servers are up. We kind of treat the machines like they're servers, except they're outside and they're moving. So we monitor everything down to the millisecond. 90% of the time we can fix stuff remotely, send an over-the-air patch, restart a node, or whatever it is that we need to do. But we don't have a disengagement kind of metric because there are no humans to literally take over.
no, but there's a teleoperation, like a remote person can boot in, and let's say it's stuck somewhere. Somebody.
We can teleoperate it. We do not allow our clients to do that.
Okay. Thank you.
Good. That's a great question. Well, we're running out. We're at the end now, and I want to thank everybody for coming for this interview and conversation. I want to thank Bill, and we wish him the best of luck. I know he's raising money, and he's got a website where you can invest in this product if you think it's interesting. So I encourage you to do that.
I appreciate that. Yeah, we're backed by 6,000 investors across the country that want to make a difference. You can literally go onto Knightscope.com and buy shares in what we hope to be our pre-IPO offering.
Great. Well, thank you very much for coming today.
Thank you, everybody.